Hello, and welcome to the mini lecture from our Chemistry 1412 class with Dr. Elizabeth Bell. Today we will be talking about entropy and the second law of thermodynamics. Some things happen in nature all on their own, and some things do not. If no energy, either in the form of heat or work, drives a change, that change is spontaneous. An example of spontaneous change is ice melting at room temperature or a hot cup of coffee becoming cold. A non-spontaneous change is something which needs an input of energy to occur. That energy can be either heat energy or work energy. Entropy helps us understand why some changes are spontaneous and some are not. Entropy has a symbol of capital S. Remember that capital letters represent state functions. A state function is a quantity whose value does not depend on the method used to measure it. This will come up again. Entropy is a measure of disorder. The more disordered something is, the more messy it is, the higher its entropy. The more ordered something is, the less its entropy. When a substance is going through phase changes, the entropy changes as well. Going from a solid to a liquid increases entropy. A solid is a neat, ordered arrangement of atoms or ions. A liquid is a free-flowing fluid of the same atoms or ions. More freedom of motion means more entropy. A gas has even more freedom of motion because its volume is not set. Going from solid to liquid and from liquid to gas increases entropy. Going from gas to liquid and from liquid to solid decreases entropy. Gases have the most freedom of motion. Liquids have a greater freedom of motion than solids. More complex molecules also have a greater freedom of movement. During phase changes, temperature remains constant. Each phase change of every compound or element has a temperature and a change in enthalpy. If you divide the change in enthalpy by the temperature, you can calculate the change in entropy. The small circle exponent denotes standard conditions. Entropy is a state function. State functions are quantities whose value does not depend on the method of measurement. What that ends up meaning is that we can use the standard molar entropies to calculate the change in entropy of a chemical reaction. To do this, take the sum of the standard molar entropies of the reactants multiplied times the coefficient of each reactant in the balanced reaction and subtract it from the sum of the standard molar entropies of the products multiplied times the coefficient of each product in the balanced reaction. Standard molar entropies can be found in a table in the index of your textbook. They can also be found online. The second law of thermodynamics suggests that there is a natural tendency of reactions to have an increase in entropy. The phrase natural tendency implies that spontaneous processes always have an increase in entropy, but this is not true. There are some reactions that are spontaneous even when they have a decrease in entropy. The reason for this is that when a spontaneous reaction has a decrease in entropy, it will also be exothermic. This release of heat will increase the entropy of the surroundings. It increases the entropy of the surrounding by more than the decrease of the reaction. So the total entropy increased. There are two parts to the entropy change of a reaction. Sometimes the reaction is also called the system. There's the change in entropy of the reaction, and there's the change in entropy of the surroundings. Add these together to get the change in total entropy. The second law states that for any spontaneous process, the total entropy of the universe increases. Thank you for viewing the mini lecture over entropy from our 1412 course with Dr. Elizabeth Bell. Please go to Sapling and do the associated assignments at this time. If you need help with anything, do not hesitate to ask. I am happy to help.